Hello and welcome to Diplomatic Derivatives. In today's video, we're going to talk about permutation and symmetric groups. We are going to cover this topic in 5 parts, and today in the first part, we'll be talking about what permutations are, what is the equality of permutations, identity permutations, and product or composition of permutation. It's important that we do this topic before we move on to the other major topics of homomorphism, the fundamental theorems of homomorphism and isomorphism, because examples from this topic will be used there. So once we are thorough with this topic, we'll be able to understand those concepts in much better way. So let's see what permutation is. A permutation is a bijection, one-to-one and onto function from a set to itself. So make sure you remember one thing. In permutation, we are having only one set. We are not talking about two separate sets having a relationship. It's one set, and the function will be from that set to itself. Okay, for example, here we have one set 1 2, and we are having that function of that set with itself. Okay, and that function is bijection, which is 1 1 1 to 1 and onto function. So each element has an image here, and each element here has a pre-image over here. Okay, so this is what's permutation. And remember that each in permutation, what happens is it rearranges elements without repetition or omission. So 1 2 will be rearranged to 2 1. Okay, there won't be any repetition, so you will not write 2 twice, or you won't write 1 twice. You will just write it once, because you're just rearranging. You're not adding something or you're not reducing something, so there is no omission as well. In simple words, what you're basically doing is a reordering of distinct objects where order matters. So make sure you remember the part about the order, because order matters. In other words, what you can say is permutation is also a combination, because you're rearranging elements and making another combination, right? But the difference between combination and permutation is that in permutation you know the order matters. In combination, the order does not matter. For example, if you have a group which has 3 elements A, B, C, in combination it will be equal to BAC, which will also be equal to BCA, because there is no repetition or omission, but you're just rearranging the elements, and it's still the part of the same group, right? But in permutation, the order matters. So ABC will not be equal to BAC. These are two separate things. So for example, if you have a permutation 1 2 3, it won't be equal to 1 3 2. These are two separate permutations. Okay, we'll take examples and try to understand the concept. So let S is equal to a set which is 1 2 3 4. Okay, and the function defined is S to S. So you are now making this permutation with this set. Okay, so I will just draw that set here. So let's suppose you have, okay, so we have 1 2 3 4. This is one set. Don't mind the diagrams, I'm just trying to make you understand. 1 2 3 4. Okay, so this is S to S. Okay, now what we are saying is, what is the function here? Now make sure you remember the part where I said the order matters. Now first of all, we have the first element 1, function on 1. So f of 1 is equal to, according to this function, is equal to 2. So what is happening is 1 goes to 2. Okay, we'll just use a different color. All right, so 1 goes to 2. Then the next function is on this 2. F of 2 goes to 3. So f of 2 is 3. Okay, the elements over here, this is f of 1, f of 2, f of 3, and so on, right? So this 2 is, what is this 2? This is f of 1. Then 3 is f of 2. F of 2 means the image of 2. Okay, then f of 3 is 4. So the image of 3 is 4. Then the image of 4 is 1. So the image of 4 goes to 1. This is one order. Okay, so 1 as in the first order. Okay, that this particular bijection creates. Okay, so this is how you make the mapping. Okay, so the image of 1, this 1 over here is in this set over here. The image of this 1 is f of 1. Okay, and what does that image say? That image is 2 according to the statement. So 1 goes to 2. Alright, 2 is equal to f of 1. Then f of 2, which is this 2, is equal to 3. So the image of 2 is 3. Then f of 3 is equal to 4. So image of 3 is 4. Then f of 4 is equal to 1. So image of 4 is 1. So how do you write it? You write the set itself in this. This is how you start making the permutation. Okay, so you have 1, 2, 3 and 4, which is the set itself. Under those numbers you will be writing the images. So 1 goes to, the image of 1 is f of 1, which is 2. Then image of f of 2, image of 2 is f of 2, which is 3. Then image of 3, f of 3, that is 4. And then image of 4 is f of 4, which is 1. Now how do you write this in a single notation? So this is that's what also that's I'll tell you that as well. So you have f will be equal to, first you start with 1, so you write 1. 1 goes to 2, so you will write here 2. Then after 2 you have 2 goes to 3, so you write here 3. Then you look at 3, 3 goes to 4, so you'll write 4. Then 4 goes to 1, so the cycle repeats itself now, right? Therefore, that's it. You finish it over here, right? So that's how you write it in a single notation. So either you can write in this form, and this form, when you have to convert it into this form, you will just look here. You will see first what you do is you write the first the elements itself. The elements come here. Then 1 goes to 2, so under 1 you will write 2. Then 2 goes to 3, so under 2 you will write 3. Then 3 goes to 4, under 3 you will write 4. Then 4 goes to nothing. Therefore, the cycle repeats, so 4 goes to 1. Okay, this is how you will write permutations. Okay, so make sure you understand this perfectly, because we'll be writing this quickly in the future topic. So it's necessary that you make sure there are no doubts left here. Alright, so this is one small example, just trying to make you understand the basic concept of permutation. Okay, next topic is equality of two permutations. Let's suppose you have two permutations, one is f and one is g. When do we say that the two permutations are equal? They are equal if and only if f of g is equal to, f of a is equal to g of a for all a element of s. So a is just an element inside the set, and the image of that element in the f permutation is equal to the image of that element in g permutation. Okay, what do we mean? Let's suppose we have one permutation f, which is 1 2 3 4 and then 3 4 2 1. Then we have another permutation g, which is 4 2 3 1, and then the images are 1 4 2 3. Right now, you see, if let's suppose a is 1, the image of a, that is 1, f of a is 3, right? Similarly, in g, if you look for 1, the image of g of 1 is what? 3. So f of 1 is equal to g of 1, correct? Next you will check for 2. So f of 2 is equal to 4, and f of 2 g of 2 over here also is 4. Then f of 3 over here is 2, and g of 3 is also 2. Then f of 4 is 1, and g of 4 is also 1. Since all f permutations are equal to the g permutation, images I mean, then the two permutations are considered equal. Okay. Next we have identity permutation. Let S be a finite set of n elements, then a permutation f is called identity permutation if and only if f of a is equal to a for all a element of S. What do we mean? That is, you have one permutation 1 2 and 1 2. So how do you write it? So let's suppose you have a set S which is 1 and 2. Okay, and you make a permutation for it. So you have 1 2 over here as well. By identity permutation, we mean that 1 is mapping to 1 itself and 2 also is mapped to 2. So this is what you get. You get 1 1. The image of 1 is 1. Okay, the image of 1 is 1 and the image of 2 is also 2. So the images are equal. So f of a, this is f of a, right, is equal to a. Similarly, f of b, let's suppose this is b, so f of b is equal to b. Therefore, this is the identity permutation. Okay. Next is an important topic, which is product or composition of permutation. So let F and G be permutations of A. Then product of two permutation is also a composition of permutation, such that the product of these two permutation, by this notation we mean that this F permutation is multiplied with G permutation is equal to F with the composition G of X, which is equal to, this can be written as F outside with G of X. Okay, remember this formula. That is, the function F of G will be written as F into G of X. Okay, that's how you do the product of permutation. Now we'll take an example. That's how you will understand this formula. Now let's suppose we have one permutation which is F 1 2 3 4 and 2 3 4 1. G is equal to another permutation 1 2 3 4 and 3 4 2 1. Acha. Now also one more thing. Do not confuse that these are two different sets. No, this is one set with two different permutations, so two different orders. Okay, so the set itself is what? The set is 1 2 3 and 4. Okay, this is what I told you in the very beginning, that we are working with only one set. There are no two separate sets. Okay, one set having different permutations. Okay, so here the set given to us is 1 2 3. How do we know that? Because it's the first thing over here, right? The first row is the set. Okay, so 1 2 3 4 is the set, and for this set the first permutation is F, which is 2 3 4 1. That's how we get the images. And for G we have 3 4 2 1. So if you just draw it here, okay, you have 1 2. So yeah, okay, I'll just take some time to draw it so that it's easier to understand. 2 3 and 4, and again 1 2 3 and 4. Okay, in the first case, in this one, what are the images? 1 goes to 2, so it's like this. 1 goes to 2, this is the first order. 2 goes to 3, 3 goes to 4, and 4 goes to 1. Okay, in the same one I'll draw the next, that is G. Okay, this is for G. So in this one we have 1 goes to 3, 2 goes to 4, 3 goes to 2, and 4 goes to 1. Okay, that's the second permutation. So the blue arrows are the first permutation, purple arrows are the second permutation. Okay, the two different orders. So what we need to do is we need to find the product of these two permutations. Okay, that is F dot G, and then the other way around, G dot F. How do we do that? We will use the formula that we just talked in the previous slide. F of Gx is equal to F G of X. So in place of X, you will write the first element, which is 1. So you will say F of G of 1, which is equal to, on this side we have F G of X. So it will be F G of 1. Okay, now what is G of 1? G of 1 is 3. So in place of G of 1, you will write 3. So you now are left with F of 3. What is F of 3? 4. So the answer is 4, the first one. Okay, that is for F of G1 we have 4. Okay, this is the product permutation, and the first one, for 1 we got 4. Then for 2, what do we get? F of G of 2. G of 2 is 4, which is equal to F of 4, that is equal to 1. So for the product permutation for 2 you will get 1. Then the product permutation for 3, using the same formula, you will get 3. For using the same formula for 4, you will get 2. Then you will write in the permutation form. So you will have 1 goes to 4, 2 goes to 1, 3 goes to 3, and 4 goes to 2. This is how you will write F dot G. This is how you will find the product, okay, using the formula. All right, now we have to find G dot F. Okay, so same thing, the same way that you will be using this formula. So in place of F you will have G, and in place of G you will have, so you just do the opposite thing. Okay, and you will find the answer. Now another trick by which you can easily, like in a few seconds you can find the answer, is that simply you just write 1 2 3 4 on the top. That's obvious, right? Now when you're doing f dot g, what do? You using the trick. Now I'm telling you the trick. Okay, so for f dot g, first you will look in g and then you will look in f. Okay, for case of g dot f, first you look in f and then you look in g. Now what are we looking at? Now for 1, when we're talking about g dot f, right? So when we're talking about 1, we have to find the image of 1 now, right? So since it's g dot f, you first look in f. What is the image of 1 in f? It's 2, right? Now you look in g. For 2, what is the image? 4. So the answer is 4. In place of the image of 1, you will write 4. We do this again. So for 2, first you look, since it's g dot f, you first look in f. What is the image of 2 in f? 3, right? Now you look in g. So 3, the image of 3 in g is 2. So the answer here is 2. Okay. Next for 3. So first you look in f. The image of 3 in f is 4, and then you look in g. So image of 4 in g is 1. So the answer here is 1. Then for 4, you look in f. The image of 4 in f is 1, and then you look in g. So the image of 1 is 3. So the image of 4 is 3. Alright, that's a simple trick. So whenever you're doing g dot f, you will first look in f and then g. If you're doing f dot g, you will look in g and then you will look in f. Alright, that's how you perform the products. Now, what is evident from this entire process? The thing evident here is that f dot g is not equal to g dot f. Hence, product is not commutative. For permutations, the product is not commutative because we don't get the same answer for f dot g and g dot f. If both were equal, then it is commutative, but in this case, it's not. Therefore, the product of permutations is not commutative. So remember the result. The product of permutations is not commutative. Alright? Now, the answers you have to write in the single notation, right? So how do you do that? For the first one, which is f, this is what you get here, right? Okay, I think I just did a mistake here. Okay, just a second. Okay, yeah. So the mistake here is that instead of writing the product, I wrote the set itself. Okay, so what we'll do is now we have to write this in the single notation form. So how do you do that? So you have 1 goes to 4. So you will write 1 which goes to 4. Okay. Then you see where does 4 go? 4 goes to 2. So you will write after 4 you will write 2. Okay. Then for 2 you will see 2 goes to 1. Right. So since it goes to 1 and 1 was the starting element, therefore the permutation closes here because now the cycle repeats. So you will close it. Okay. Now you may notice that we don't have 3 here because 3 goes to 3 itself. So it's automatically not written in the single notation permutation. Okay, automatically you won't write it. Yeah, but also when you go from this step to this one, okay, how do you do that? One thing is sure, one thing that you need to remember is whenever you're writing for 1 2 3 this particular set 1 2 3 4, you will start writing the bigger one, the bigger notation like this, right? 1 2 3 4. Now when you look at this one, you see 1 goes to 4, so in place of 1 image of 1 you will write 4. Then 4 goes to 2, so 4 under 4 you will write 2. Then 2 after 2 it ends, so therefore the cycle repeats, so 2 goes to 1. 3 wasn't mentioned, so 3 is written as it is. So isn't this similar to this one? It is, right? So that's how you will write the bigger form and the smaller form of the permutations. All right. Similarly, you can do for g dot f as well. Okay, and this is written for the main permutations. All right. So I hope everything is clear. I hope the concept of permutation and what are permutations, the equality, identity, and the product permutation is made clear. We are going to start with part 2, in which we'll be diving deeper into the permutations and symmetric groups as well. So make sure you stay tuned for those videos where we'll be jumping towards other examples and theorems as well. So make sure you like, share, and subscribe to my channel. If you have any questions, please comment down in the description, comment down in the comment box below. I will try to help you as much as I can. If you want more examples, I will try to bring those as well. Or you have anything from the CSS past papers you want me to solve some questions, I'll do that for sure. So make sure you type those down in the comment box as well, and I'll see you in the next one. Thank you. Bye bye.